Hello there, and welcome back to the Developer's Guide to Windows 10.
Hi, everybody.
Yeah, hi. I've got Nikola with me now. This is like the cool toys session, huh?
Hopefully, if people like it, yeah.
Oh yeah. So
If I build this session, if you don't like it, he built it.
but this one is called like more personal computing. But what are we saying? What is this all about?
Well, there's a lot going on in more personal computing, so we can actually just kick it off real quick. In this year in January, we actually announced Windows 10. We announced a whole lot of things together with Windows 10. We announced HoloLens, we announced the Surface Hub, and with this we said that Windows 10 is the start of more personal computing. We're starting to this new era of computers that can start sensing things around them. They can start detecting, they can help us understand what's around them. They can help us understand and collect data and work together with the cloud. You know, we have this whole mobile first, cloud first strategy now. Help us understand how to understand the world better. You know, and just help us be better and help us do things in a more natural way that we're used to, that we've kind of grown up with these methods of communicating with each other, with methods of expressing ourselves. And computers are starting to learn how to do these different things, these powerful different things, and just instead of getting in the way, instead of having us to learn how to use these computers are learning how to respond to us and how they can better communicate with us in what's more natural to us.
It's kind of you can imagine. A few decades down the road, people are going to look at a keyboard and laugh.
Exactly, exactly.
Like, what was this key layout? Wasn't it designed back in the days of mechanical typewriters and deliberately designed such that if you're typing in English, you couldn't actually go so fast that you could jam the mechanism? It's like, and this is what we're still using. It's like,
it is, and it's
crazy.
been something that people have to learn, and they used to take classes just so they can learn how to use them fast enough so they can actually keep up with what we're doing. While we've had these perfectly fine methods of communication since the early ages of humankind.
Yep.
So it's been crazy. Typewriter has been like, what, 200, 300 years now or something like that. So it's been...
So computing input methods are finally catching up with kind of more human and more natural ways of input.
Exactly. And with Windows 10 is now that it's a whole family of devices. It goes all the way from the mobile to the desktop to the Surface Hub to little small IoT devices, the HoloLens we've announced, little desktop. So it covers all kinds of devices that you might be using throughout your day, using from the time you wake up to the time you go to bed, at work, at home, to play. You use these devices that are starting to become more human, and we're putting all these different technologies into Windows 10 to learn and to interact with you in more natural ways. I guess it first started to see how we're going with the human and the human technologies and how we're going with the more personal computing. You can learn from the Xbox One.
Yeah.
So we released the Xbox One a couple of years ago, and with that we released the Kinect for Xbox One. And when you walk into a room, the Xbox One knows who you are. It opens up your stuff. You can say, "Xbox, show my stuff." It knows who you are, who your brother is, who your son is, and it can, relative to you, show you what you're doing. You're playing a game and you're using a controller, knows what person is using the controller. You can swap controllers, it knows what you're doing. You can talk to it, you can search things with it. And so we've kind of started this. We've been going around, improving our more personal computing capabilities throughout the years. And with Windows 10, we've unified that across the board, and it's super easy. And one of the easy ways that I like this picture, because it's just people communicating, and it's this little kid with dad probably, or a coach kind of communicating.
Yeah.
But the way I can explain what we call these human technologies, technologies that we're using these from early ages. When you're a kid, you can from early age you learn to communicate with gestures. Babies, they kind of try to say things or do things by the way they move, and that's kind of natural to us how to understand those. At first you don't really, but they learn and they get better with it. And that's how we communicate, and that's what's natural to us. In terms of writing, in terms of expressing themselves, you have walls at your house. If you have kids, kids love walls and they like pens and lipsticks, whatever it is, and they just express themselves in these natural ways of drawing stuff on the wall. And that's how they want to show how they're feeling and what they want, or how they want to do things. Cave drawings, etc. That's another way to do it. When you talk to like a 2-year-old kid, this kid doesn't ask you for a 8-digit alphanumeric key to know who you are. You can just look at who you are, your voice, and just understand that, hey, that's my dad. I know who you are. You don't have to go and, hi, I want to log in. Hi, okay, good. Now we can talk.
Yeah, that's right. Yeah.
You don't do that. And then we've developed language, speaking and writing, for thousands of years that we've been using throughout, Renaissance and everything. So being able to talk to computers with what we've kind of used to talk to everybody is kind of what the human technologies are all about, and how we have been improving the more personal computing in Windows 10 and where we're going in the future.
Because we've been trying to do this with computing devices for a long time.
Very long time, yes.
It's one of those things that's probably the technology has finally come of age, and we've got sufficient computing power and smart software and cloud services and all this kind of stuff that's all making interesting new things possible that we just couldn't do 10 years ago.
Absolutely. I mean, we've touchscreen, for example. Touchscreen has been available since 1976 or something like that. We've had touchscreens, but they weren't that powerful. The software wasn't there, the hardware wasn't there. We introduced the tablet PC 10, 15 years ago. Bill Gates did it, but the software wasn't there, the hardware wasn't there. I mean, the software was there more than the hardware. The hardware couldn't keep up.
Also, we've been learning, haven't we?
We've been learning a lot,
learning about touch screens and how to interact with people, and perhaps our first efforts. You improve all the time, don't you?
We've had many different ways how we've improved, and you can see that in the history of the device that we released. I don't know if you remember the original Surface that we had that was just a table that, it knew contextually what you're touching, you knew the stuff that you're putting on the device, and you can just get information that way, and we've kind of been learning from that. Yeah. So being human and using these ways that we've been using for thousands of years is what we're trying to do with more human technologies, and trying to teach computers to do this. And I want to talk about 4 of these different, what we call human technologies. I mean, of course, there's more than this, and there's new devices coming out. They're going to support more and more of these human technologies. But these 4 kind of want to just touch on a bit, and these are things that you can actually implement in your applications right now and use them to make your application more human-friendly and more personal computing-friendly. So let's start with gesture. So gesture has gesture. What I mean by gesture is everything from using your mouse to do something, using touch to do something, using even gesture in the air to do something. We've kind of been conditioned when we use computers, and you can see this with, I go back to the young kids, but you can see this, how they expect things to work. They just expect to touch things. They just expect things to just work. A kid goes up to a TV and tries to touch it and says, "Dad, the TV's broken, it's not working." There's something they expect. And we've been growing with, as we said, how to improve this. And with starting Windows 8, we've made it a lot more touch-friendly. We've added a lot more controls for developers to use into their applications. They support gestures. We have a whole engine for creating your own gestures and supporting your own gestures. And it's all about, enabling people to do what they expect they want to do. If I want to touch something, I should be able to touch it. If I want to, move my hand this way, and the computer should be able to know, hey, he's trying to do something by moving this. It's about learning about doing this, and we're enabling this. And Windows 10 even more, we have even more capabilities for how you can improve on using touch in your applications. I think the best example here is the controls that we have and the manipulations engines that we have inside of Windows 10. But one example is drag and drop. Drag and drop has been, something, you think, well, drag and drop.
Wow, that's like, when did we first have that? It was
exactly.
Like Windows 95. No, before that.
Yeah, it's been a long time. Yeah. It's since we had a mouse, you can drag and stuff, and you can, so it's something that's been expected for a platform to do. And the whole premise of drag and drop is being to take this here, put it there, and do something. I wanted to touch this and just drag it there, and I wanted to do something. And we've been enabling this in the platform. And in Windows 10, we finally have now ability to be more creative about how you do these drag and drop little features. I just want to show a quick demo of how it actually works in Windows 10. It's just a very simple demo of the same application we've been using so far.
Yep.
Let me just switch over to duplicate. So here's the application, and if I run this application, you can see that it's restoring all the packages. Apparently, I haven't run it in a while. There it is. So it's going to enable us to, if I want to add an image to this, if I want to just drag it, I can just do that. If I want to create a new item just by dragging something, I can do that. And it's very simple to add. I think I actually enabled debugging without running the application. So let me go ahead and disable that real quick. Yeah. There we go.
Yeah.
That's from a previous demo that we did.
Yeah, that's right.
There we go. So here's the application. It's the same applications that we've been using so far. You can see it has your beautiful picture there.
Yeah.
Now, you know, what do you expect is if I just want to replace this image, I should be able to just drop another image to it, right? If a kid comes on here, they won't know to go, oh, I need to click this button and go find something. Just make it a lot more simpler. So, you know, just drag an image and just drop it on there. I'll just enable this real quick. There it is. So if I just drag it, you know, I can just replace the image just like that.
Yeah, nice and easy.
Or if I just want to create a new item, why not just drag a new item right there and just create a new item from that? You know, it's simple as that. Or what if I just want to take this and just put it into different applications, or even throw it to a different screen? What if I just have two devices that want to talk to each other? I should be able to do these different things. And we're enabling these different things with being able to do second screen experiences, being able to do proximity detection, all those different things that the computers now have built in, the sensors. The software can now use to actually make more experiences there. You can just use. You don't have to teach people to use them. They can just learn how to use them really quickly.
Yeah.
Just to show you quickly what the code looks like for this.
Because it's quite a simple API, isn't it?
It's very really simple API.
And something that's brand new for sort of what formerly were called Windows Store apps, which are now just universal WinRT, XAML, you know, UWP-based apps. We've got all these APIs in now, so here we go. Oh, yeah.
Exactly. So it sort of was available before, but it wasn't available for across application, across platforms, or from the desktop.
You could drag items in a list view.
Exactly. You can do it kind of in the same application.
Yeah, but you couldn't drag from one window to another.
Exactly. So this is kind of an extension on top of that. So if you look here, we have a couple events. So allowing things to be dropped on top of this element. Sure, true. Give me an event when something's over this element. Give me an element when somebody drops something on here, or when somebody leaves. Very similar to how we use the mouse events, for example. You know, mouse in, mouse out, exactly.
Yeah.
If I actually want to see what these do, I can go to the definition and see that on grid over, when there's something, when I'm dragging on top of it.
When you're dragging over something that is a valid target,
exactly.
you can change the icon and you know, a bit of text on it.
Absolutely.
So you're giving visual cues to the user that, okay, I could drop it here.
I can do this, exactly. So you can see here I'm saying that, okay, this is going to be a link. This is the user knows that it's not going to move the item, it's not going to, you know, copy it, it's going to just kind of link to this item, so it knows that it's going to be there. For example, you mentioned changing what it looks like, the whole experience. I can add a caption that says, hey, drop me now. You know, so give kind of hints to the user as they're dragging on top of it. You saw that I had a kind of a gray background show up, kind of giving a cue to the user. You can actually, I'm just making that visible whenever the user is on top of it.
Yeah.
If you use the shared APIs in Windows 8.0 and 8.1, actually this is very similar how this works. We have a data view element that actually contains all this data. So if a user drops an item on top of a grid that has enabled drop, you can get all the data that's stored into this data view element. So you can get, for example, in this case, it's just a file. So I can get the file, but it could be anything. Could be an image.
As with the share contract, it could be image, could be HTML, could be a custom file.
I drag a link from another application, I drag a text from a different application.
So the target presumably at some point says, I'm happy to accept, or presumably if you drag over and it's incompatible, you must declare on the target, okay, I can accept files or something somewhere.
Absolutely. So if you look at the drag over, that's where we actually set the accepted operation.
That's where you're saying.
You can actually say none, and then you won't let anything to drop there.
Okay.
That's how you set what you want it to drop.
Yeah.
And then here, once you drop it, you can check to see what the file is and what you need to do with that. And then finally, I have another event for when the user leaves. I simply just want to, you know, hide the element that gives the user some hint. So it's a very simple API, and it just takes literally 5 minutes to implement. But it's something that just makes it so much easier to do these different things. If I added all these images to this application just by dragging them, if I had to, you know, use the button, I would probably, you know, take me a lot longer, and probably didn't like myself that much.
So you still got to leave the like the app bar buttons, the take a photo. You probably still want to leave those for people who expect those to be there, but then more.
And on the phone, there's no notion of multiple applications. So how are you going to drop that?
Yeah, and of course you've got to remember this app's going to run everywhere. So.
Exactly. So its ability to detect and be usable across the spectrum.
Yeah.
You know.
Yeah. Cool. Nice.
Cool. So, and I talked about the Kinect, and I just want to touch a bit more on the Kinect here. So Kinect was released the original Kinect was released a long time ago, and then we had the new Kinect version 2 released about 2 years ago. And it just made it so much simpler to make all these powerful interactions with the computers, with using gestures, using voice,
Yep.
etc. So for those that haven't used the Kinect before, or that are not familiar, it's a brand new camera that has many different sensors on top of it. I don't have one to show here, but that's what it looks like. It has an infrared sensor, has a depth sensor, has an array of microphones. They can detect where the user sound is coming from, so they can know where the user is just by sound or just by looking at them. It has the ability to detect people, detect what the people are,
Yeah.
who they are. You know, there's applications out there that have done work to detect the age of the user, to detect how old they are, how if male, female, you know, to detect all these different things. As a developer, it's very easy to just get started with this, because you just, for example, for a body, you just get a list of these are how many bodies there are. This is where the hand is. This is where the arm is. Oh, they're jumping. They're not. You can. Oh, they're leading this way. It's just very simple APIs to use, and you can do a lot with this. And when you pair this up with the power of the cloud and things like machine learning, you can do even more than that. You can just learn a lot more about the environment, and we're getting to an age where devices like this are enabling more personal computing across the board, across everywhere. So it's very cool, and we've done a lot of cool stuff with Kinect. Partners and the community have done a lot of cool applications with the Kinect. They've built applications that can understand the environment, what people are doing, so they can do different things depending on that. They allow us to interact with machines in very cool ways. You know, you can just wave your hands and do,
Yeah.
you know, Minority Report kind of thing that we thought it wasn't possible 10 years ago.
Yeah.
You know, being able to play a game just by kicking a virtual ball, for example, or, you know, mixing realities, etc., doing virtual reality. And then with the V2, we've enabled these new capabilities in a lot more fidelity. That just makes it usable for everybody, everywhere. And we've seen this across the board in many different areas and markets. In retail, they use it to, for example, to, you know, just virtually show you what the clothes will look like on you, for example. You know, it's instead of trying to close, you can just see what it looks like on you. In manufacturing, you don't have to touch dangerous machines, or if you're dirty, you don't have to, you know, turn something on and off. You can just talk to the Kinect or to the device, or just do something, wave at it to stop, or do whatever. In healthcare, where it's important to be clean and sanitized, you know, Kinect or device can detect if you wash your hands or not. You can detect, you know, it can try to do something for you, so you don't have to touch something that's dirty, for example. In entertainment, of course, in education and training, we've had a lot of applications to help users to learn, to you know, play games and just have fun. So it's been a revolution.
Sure.
And it's been happening a lot faster and faster. And it's,
I suppose you're more likely, obviously, it's going to be applied to these kind of verticals, really, isn't it? The specific scenarios, and using that power of the connector
exactly.
open up these new ways of inputting with the system and the software.
Absolutely. And you know, we took maybe 10 years to get from not being able to do this at all to being powerful enough to do all kinds of, you know, cool stuff like this. Imagine what's going to happen in the next 10 years with all the stuff that we have right now.
Yeah, right.
Yeah.
Yeah.
So we talked about gestures and how kind of the history of that. I want to touch a bit on ink or
so
pen.
Inking, it's like, it's the oldest way of us writing stuff down. It's like, you know, from the earliest, you go back millennia and people were scratching things on cave walls and stuff, you know. It's this idea of drawing something. And we've tried to do it with computing for a while.
For a very long time, yeah.
For a very long time, but there's always this, it's just not quite ever kind of felt really natural.
Not natural, easy, or, you know, writing is important because it's quick. You know, you want to draw something by your pen, you just write something. So, you know, for example, if I want to take my Surface Pen that I have for the Surface that I'm using, let me just select pen here, I can, for example, you know, start writing. So, excuse my handwriting. So writing is immediate, you know. I can just grab it, for example, with the Surface Pen and the Surface 3 that we have, Surface Pro 3, you can just press the button, device locked, unlock, doesn't matter, it opens up, you know, a way for you to write immediately, you know, and you can write very, you know, just put your notes really quickly down. It's expressive, you know, you're not limited to 100 and some keys that you have on the keyboard. You can do whatever you want, you know. Let me just write that out.
And I know with Windows 10, I know we invested a lot in right into the low hardware levels about making sure that driving that latency out of the system that was part of the problem in the past in making, you know, when you write on the screen, the look and feel of it, it was just that lag that kind of made it feel awkward. Whereas with the next generation, you know, the new generation of devices we've got out and the new Windows 10 software, it's like really a much better, more natural experience.
Absolutely, we've done a lot of work in the very low levels of the operating system to get the latency down to less perceivable levels, where you can actually see where the drawing is when your tip of the pen is actually very close by and actually falling a lot faster.
Yeah.
And there's videos out there you can actually see. I don't have any here, but you can see how the improvements that we've done from 8.0, 8.1 to Windows 10. And we've built inking into Windows 10 to the platform, both mobile and desktop, and the Windows 10 devices. So, for example, one of the examples that I would like to show is Edge. I'm sure that people have used Edge, but if they haven't, they might not know that you can actually do very beautiful inking in Edge. And the reason why I actually like Edge is because it's very easy to show how this looks like.
Yeah.
So, for example, if I hit this button here, it allows me to express, write notes or whatever I need to do here. So, you know, I can select the pen right here. I can kind of draw this, you know, make it say, oh my God, look at that. Look at that, you know.
Yeah.
I can do that. Or, you know, if I want to write notes, what's cool that we've built in, and this has been available for a while in Windows, but the ability to actually write even in anywhere, and the built-in keyboard with a pen. And we've continued to improve this, and it's been amazing how this works. You can just now, this is awesome. You know, you can just write and it just recognizes this. And come on, I can't even read that.
no, it's pretty impressive, isn't it? Yeah.
Yeah.
I was looking at, what is that word? And the computer said, it's
awesome. You know.
Yeah.
So we've been learning for years of how to do these different things, and we've been improving the platform so much that it's becoming even better than writing on pen, because it's just available more than pen is available. You know, things like being able to detect pressure, so it kind of looks natural. So you can see if I'm right here, I can, you know, the line is not that thick. If I press more, the line is thicker. You know, it's actually, you know, like a pen would react. So, you know, the wording looks exactly like pen. So it's pretty cool. You know, I can actually show you one that I did yesterday, which I kind of like. See, this one's on front yesterday.
You have too much time.
I have way too much time. Yes.
That's very nice.
Yeah.
Yeah, lovely.
So it's pretty cool. So for developers, what does this mean?
Okay, yeah.
You know,
now, let's cut to the chase.
Let's get to this.
How do I add this to my app? Yeah.
So we've made this super simple now. In previous iteration of Windows, if you wanted to add things like this into your applications, you had to do everything yourself. You had to render everything yourself. Performance wasn't that great. So we've come up with something that's called DirectInk. It's a new platform on Windows devices for Windows applications.
Right.
It supports PCs, tablets, and phones. So you can just It's essentially a control that you add into your application and handles everything for you. It renders everything on a DirectX level. You know, it's off the UI thread. Everything, the same controls that we use in things such as OneNote and etc. is available to everybody to use right now onto their applications. And they have full, confidence of how the application how it's going to work, because it's been tested and it's something that it's been backed by all the research that we've done in Microsoft to enable this more personal writing way of expression.
Nice.
It allows you to do many different things. It allows you to change how the pen looks like. If it's a pen, does it act like a headlighter? Does it act like a whatever? You can customize any way you want. You can use pen if you want. You can use touch to write. You can use mouse to write. You can control all that. How the stroke is. You can do things such as recognizing what the user has written. So you can just take the stroke data and recognize it, save that, load that later on, use it in any way you need, mix it with real images. All that is built into a platform. You can do that. So instead of just talking about it, I actually want to show it how it looks like on the to-do applications that we've created. Let me just switch to duplicate. There we go. So here's the application. So let me go ahead and run it one more time. I've kind of added a few more things than you have in this application. So for example, here's the shoot this week on Channel 9, for example.
Yeah.
If I click on notes, it takes me to this ink canvas or thing. So I can use the pen and I could I can just start writing. You can see I get the whole pressure sensitivity. You know, I can start typing, hi, hello. You know, if I put my my hand on the screen while I'm typing, you know, it knows that I'm doing it, so it doesn't recognize it. It doesn't mess with the writing.
Doesn't kind of blur the
no, it doesn't. It doesn't touch the
so
start button.
You're not having to do this kind of weird, oh, I mustn't touch the screen with my partner.
It's very smart to know that, hey, this guy's writing, so it's very natural. You don't have to kind of just do this, just like you did on paper, you know. So how does this work to add it to your applications? So if you look into the page that I have now, let me switch over. So here's the XAML, and you can see here the only thing that I need to add is just this thing control called ink canvas. That's it.
So presumably that would need to be the bottommost element if you wanted to, you'd overlay if you had some actually other XAML elements on the page.
So it will be on top. So you actually draw on top, and it kind of sees what's underneath it.
I'm just thinking in terms of rendering order because it tends to render top down. So you'd express that XAML element that's in Canvas at the bottom of the list. So it overlays
exactly,
everything else.
In terms of how it's overlaid in terms of layers, it's going to lay on top so you can actually see everything underneath the in Canvas.
Okay.
So that's all you have to do. Now, if you want to customize this and add more functionality to it, you can do very cool implementations. So for example, if I go over to the code behind this, let me see, go here. So you can see here I've commented everything out.
Yeah.
But if I uncomment this, you can see that I can change. Let me uncomment this. Oops. So you can see here I can use what's called ink drawing attributes to change things such as what the color of the user that they wanted to draw.
Yeah.
What is the size of the pen that they're using? Is it more of a rectangle? Is more of a dot, for example? You know, you can control all that. Does it act like a highlighter so you can see everything underneath? Does it act like a pen? Does it act many different ways? Is it kind of cursive, or how does the stroke looks like? You can also change to see what the input devices are. So right now by default only the pen works. Nothing else works. But if I use the input device types, I can specify a mouse. I can specify a pen. I can specify touch. So right now I'm enabling mouse and pen. So if I want to use the mouse to draw, I can do that. I don't have to use a pen. And then I can use the finger for something else, for example, to do selections. Now that I have enabled that, I've also created methods for ability to load and save what the user has written, so then when they go back, they can see what they've done and modify it.
It's all well being able to easily draw, but you need to capture that in some way.
Exactly. So, for example, in the save method, the only thing you actually have to do is save everything to a file. You just create a new file, for example, and we have this new method called load async. Essentially, what it does is takes a stream from the file. You just create a stream from the file, like a write stream, and then you call the load async to write everything to that file, and it just saves it. And what's cool about it, it saves it in a GIF format, or GIF, however people say it. It saves in a GIF format that also has the stroke data, so you can open it up in Windows Explorer. You can see it as a as an image or whatever you've done it. You can load it back up. You can still have all the stroke data the user has written in order, etc. If you want to load. This was being able to load file. Yes, being able to load into it. The save to file is the save async method. It's the opposite of that. So you save this and you get it to the file, etc.
Nice, simple stuff, huh?
It's very simple. Then if you want to change the properties, if I run this application again, you've seen I've added some controls, some ability to, as I'm typing, I can change the color, I can change the pen type, etc. So there's some methods here that allow me to do that. So if I go back to the file here, if I can write in red now because that's the default I've set. But I've created this little control here that anybody can create, and the code is very straightforward. It's just buttons and etc. So I can change the color, so I can start writing in that color.
So that's a custom control.
Exactly, it's a custom control that you can create. Change the type, calligraphy. So this makes it more of a rectangle. You can see I still get the pressure sensitivity, and it still looks very pretty. Let's go back. Just close this a little bit and keep it running. The way you do this, you simply just get the same thing that we did at the beginning. You get the ink drawing attributes from the ink presenter. That's a property on top of the in canvas, and then you just change this property as you need to. What's cool about this, you can also do things such as recognizing what the user has written.
Right. Yes.
Right. So you can write
that's
something.
Quite common thing that you want to be able to.
Exactly. So if you wanted to save this as text, you can do that. So for example, let me clear this, change this to ballpoint, kind of not red, and I can medium. So if I write hi, oops. The cool thing is I can use the buttons on the pen. It automatically knows that I want to erase. You know, it's all built in. I don't have to write any code for that.
Nice.
So hi Andy. So I can say recognize and say hi and doesn't recognize Andy.
Close enough.
Exactly.
Kind of crazy why you got there. So yeah.
Yeah, let's fix that.
I don't know what that is.
Hey, I'm a programmer. I don't.
Yeah.
Is that better?
Yeah.
No,
I think
maybe not.
No, I might do it.
No, hi and. It doesn't matter. So it recognizes, you can recognize text. How do you do that? So we have this new object called recognizer. So it's a ink recognizer container.
Yeah.
So you create a new ink recognizer container and simply just call an API called recognize_ink. It's that simple. You pass the strokes of the ink canvas that are inside the ink presenter, and then you specify that you want to recognize all of them. Or you can just specify you want to just recognize a specific set of strokes. You can select specific strokes, say recognize what this means, kind of thing. It's more powerful than this. This is just to illustrate the API, but you can also change the language that's supported on the device. So you can choose between different languages, so you can recognize in different languages. So it's a lot more powerful than that. And then here I simply just get the text candidates for each one. I just go through all the recognitions and I just print it out.
Yep.
What you can also do is, you get information about where that word was recognized. So, for example, I can simply, I have a different canvas I've put underneath this canvas, just a regular canvas. I can just put elements in and put them in the location where the elements were detected. So let me just uncomment that there.
So that's underneath the ink canvas, yeah.
Exactly.
Yeah.
So now, if I just run this, there it is. There it is. If I added this, hi, let's try this again. Maybe I do this. Maybe that worked better. Recognize hi and two. But you can see now it actually puts the text right underneath, so it knows where the text was, etc. So it's very simple to use.
Okay, so
And one thing just before I'm done with this demo that I want to add is, you saw that little control that I created for thing. But actually there's a control that already the Visual Studio team, Link Studio, has created.
I was kind of leading towards that.
Exactly, yes.
Sure, have to
so you can see it here. There's an ink toolbar. So it doesn't come with the platform. It's sort of a beta the beta control, but you can download it from a Visual Studio Gallery. You can just search for ink toolbar. Just download it from there and then just include it in your application. Just point it to the ink canvas that you want to use this for. And this is similar to the one that's used in Edge. It looks exactly like the one in Edge, and it allows you to change color, change the size, change what kind of pen you're using. It's actually just drag and drop control. You don't have to write any of the code that I've written in this page. You can just include it in your application.
Okay.
So let's just see what that looks like. So you can see now I have this little control.
Nice.
I can change the color to that, change the size to biggest, and it just works.
Nice.
Very simple to use, and it actually looks really pretty.
It does. Looks good. Yeah.
Yeah.
Awesome. Yeah. And that's like not a lot of code or anything. That's
no,
really,
it's very
really
simple
easy
to use. We've made it.
Yeah.
We've received a lot of feedback from partners that they had to write a lot of code on their own. Recognize everything, and they had to write everything. Didn't have access to the lower parts of the operating system, so they couldn't get the performance code that they needed, or didn't have the time to do it. So us doing this with all the resources and knowledge that we have, people can just reuse this work, and they don't have to spend the time, writing code.
Very nice. Very nice. Yeah. Right. So I'm intrigued. What we got next?
Well, just to end up on this, I just want to touch a little bit on the Surface Hub. Now, this is a universal Windows application. So this doesn't just run on desktop. It also runs on mobile. You can use your finger to write this, but also runs on the Surface Hub. And for those that don't know, the Surface Hub is a new device that we announced. It's huge, 84-inch device that it's basically meant for collaboration between users, and it comes with many cool features. But one of the things it comes with is a state-of-the-art pen and touch experience. It comes with a specific pen, and it's been meant to, to showcase how the Dutch platform works. So if you build these applications using the in canvas, this works beautifully on the platform. You can have up to several people writing at the same time on this big whiteboard looking board, and it just looks very natural as if you were at a whiteboard, and it's a powerful platform. And this is one of the devices that we've been creating to showcase more of what the personal computing experience can be and how we're pushing that experience forward.
Nice, lovely.
Cool. Finally, my favorite part, speech. Yes.
Yeah.
So most people know speech as Cortana. So and a lot of developers are curious about how they can actually implement Cortana into their applications.
But it's probably worth mentioning, isn't it, as well, that Cortana at launch is available in certain territories, but not worldwide. But this speech technology, you don't absolutely have to have Cortana. Cortana is a good way of interacting with the speech capabilities of Windows 10, but on systems where we haven't rolled out Cortana yet, you can still build in speech input and output into your apps. Absolutely, yeah.
Absolutely. And when people ask me why should you think about Cortana and speech, is exactly that. Cortana is not available everywhere, but it might be available in countries where your application is available in. So you might want to. That's why you want to include it.
Yeah.
This parts of the speech platform that are not part of Cortana, that the majority of the speech platform is not part of Cortana. This still works. So you can still use a lot of these APIs and controls. And a lot of new countries are coming up to support Cortana. We've announced that we're doing a lot of testing in countries like Japan and China that are making more personal experience. So exactly why you should be actually writing applications to support this experience. And we've had Cortana since 8.1 on Windows Phone. It wasn't available on desktop. Windows 10, now it's available on Windows desktop, Windows Phone, the tablets. It's also coming to the Xbox we've announced. So more and more Windows 10 devices are supporting these Cortana APIs, etc. Some of the APIs that are not part of the Cortana, but you can still use in the application even if you don't want to use Cortana, are ability to do speech recognition and speech synthesis. So ability to recognize when a user is speaking and actually speak back to the user. And we have two APIs for those. It's the speech recognizer and the speech synthesizer. And they're actually very simple to use. And instead of just me talking about how to use them, I can just show you how they work.
Yeah, great.
So I have a quick demo on that. So I've built this little application. I don't have many friends. I'm not a popular guy. So I built the application I call Best Friend. So it's actually a very simple application. There's a bot, a fake person that's on the other end that I can talk to, and I can just simply talk to them, and they can respond back. Apparently they're busy, but I can I can say, start listening. Start listening. How are you today?
3 lives have I, gentle enough to soothe the skin, light enough to caress the sky, hard enough to crack rocks. I am water.
Very profound.
You seldom find a treacherous elf. Well, there are the drow and the banshee, but I won't talk about them. So trust me.
Stop listening. Yes.
Well, that's very entertaining. You could. I can see why this could be quite interesting.
Yeah, it is. Okay, I'll stop that. So it's very actually simple to implement these APIs into your applications. Yeah. So here I have the source code for this, and if you're interested, this is actually available on my GitHub. The full source code of this application. You can just download it and use it. So first things first, if you want to speak back to the user, it's actually very simple. We have the speech synthesizer.
Mm-hmm.
You create a new speech synthesizer. You take some string, or you can actually specify more than a string. You can specify an XML file that has things such as how to pronounce things, or a way to make pauses, etc. So you can actually
give hints on how this should be spoken.
Exactly, yeah. But in this case, it's just a regular string of text that I wanted to say. Yeah. And I've set up a media element that can play back the stream that this API returns. And you don't have to use a media element. You can use a background media player. You can use whatever that can play this audio stream. And I simply just play it. Yeah. And that's it. And 3 lines of code, you can get the machine talking back to you in a Cortana voice.
Right.
A little bit more work, you can make it even more natural.
Yeah.
If you want to talk, you want to understand what the user is saying, there's 2 things you can do. First thing is you can create a speech recognizer that can, they can recognize something the user has said, automatically decide when the user has stopped speaking, and just return text to you. So to do this, you first need to create a speech recognizer. you need to set a compilation result. Here you can set your own personal compilation result that you want to be more specific or want to understand. If you just use the default, it's going to use our own speech compilation, which uses the cloud to understand better.
Can you just expand that?
Yes, sorry.
People? Yeah.
To understand better what the user is saying.
Yeah.
And finally, you can also add a hypothesis generated. This will get called as the platform is understanding, is listening. So you saw in the application, as I was speaking, text was appearing. So as I'm speaking, text can, you can get the text as the understanding.
Okay, so you're giving some feedback.
Some feedback that it's understanding what you're saying.
That's right. Yeah.
And when you want to listen, once you've initialized this, it's actually just one API. It's the recognize as sync.
Yeah.
You just call recognize as sync, returns a string. Once the user is done listening, automatically stops and returns that string. This doesn't use a UI, but there's actually an API called recognize with UI async that actually pops up the UI. You start when I said stop listening, popped up the UI.
Yep.
So it pops up a UI that says, oh, some feedback that it's listening, and you can add more commands that way too. There's also a way to do continuous recognition. So if you want to set some commands, like you saw, I said start listening.
Yes.
So those commands can be set for the lifetime of the application.
Okay, so while the app is running, it's kind of passively listening for key phrases that you can trigger it. Yeah. All right.
So to initialize that, it's very similar to just how you initialize the regular recognizer.
Yeah.
Use the same speech recognizer. But in this case, I set up some more constraints. So I set up my own constraints, and I've just set up a start listening, just one, to know when it finds this phrase, let me know kind of thing. And then I've also set up to compile it. And once I've set up an event, once it recognizes something, it calls the results generated event on the continuous recognition session.
Yeah.
So it just calls that event.
Yeah.
Once I recognize something, I can see what I've recognized, and I can do whatever I need to do to recognize that.
Okay, cool.
It's very straightforward to use.
It's nice and easy. Yeah.
Yes. So those are available everywhere on Windows 10 desktop and mobile, so you can just use them within your application. They don't require Cortana at all to use.
Cool.
Now, what if you want to use Cortana?
Right. Yes.
So.
Oh, sorry. Just before we move on, obviously the Reco bit of it, that you need to have a connection to the cloud for that.
Absolutely.
Don't you?
Yes.
So it all goes.
If you use the default, compilations.
Yes.
You can put your own compilation that doesn't require the cloud.
Okay.
So you can use your own engine, whatever, your own dictionary that can be recognized, and they can be all completely offline.
That happens locally.
Exactly.
Local computing power. Okay.
Absolutely.
Yeah. So you're by that, I suppose, when you supply a dictionary, you're saying this is kind of an XML file that just constrains the terms that you can recognize.
Exactly.
So,
yep.
And then we've got enough power locally. Okay. Nice.
Absolutely. Now, if you want to use Cortana, we've had several features already available to Windows Phone developers for Cortana. They could essentially activate an application. A user could say, in this case, best friend, I want to talk, and best friend could open up and start talking to me, kind of thing.
So the voice commands.
Exactly,
so
kind of voice
launch,
commands. And those are actually available even if your Cortana is not available on the platform.
That's
you don't have to use Cortana. You can just go to search and kind of press the listen button, and you can kind of.
I suppose the thing about Cortana in that context is that it's right there. It's on your taskbar. It's easily. You know that's where you speak to, and so it makes it more discoverable. But like you say, speech commands are available on systems where we haven't got Cortana.
Absolutely. Yep, exactly. What's new now in Windows 10 is also the ability to execute information or retrieve information from my application using background tasks. So I can ask Cortana to do something on behalf of my application, so my application doesn't actually go into the foreground, doesn't get started up, but I can still get some information. For example, if I want to get the weather, if I have a weather application, I can ask Cortana to ask my application's background task to get the weather, and Cortana can display that information as if Cortana were saying that. So that's completely new, and it's a way to extend Cortana in a more natural way, so I can actually speak to the machine and while you're driving or whatever you need to do. And I find myself when I need to add two numbers together while I'm doing something, hey Cortana, what's 1 + 2 kind of thing. And it kind of does it for you. So I've extended to do to enable this, the ability to show you how to do this. So let's go ahead and do that. So here's the application. If I run it, I'll show you what it does, and then we can look at the code.
God, I started building this to-do thing as this dumb sample, and it's growing into this quite amazingly featured app. It's like,
but under this, I think we can.
I think we should ship it.
So I ship it. I'm absolutely right. So I can launch the application just by talking to it. Hey Cortana, show my to-do.
All right, on it.
And launches the application, you know,
Yep.
and shows me what my to-dos are.
Yep.
But as I said, you can also, you know, have Cortana tell you what your to-dos are. You don't have to, you know, do that. Hey Cortana, what's on my to-do?
Your top to-dos are, shoot this week on C9, prepare Cortana demo for MVA, feed the ninja cat,
gotta feed
new
that
item
cat.
from image.
You know,
All
so you
right.
can actually get this data from the application. Didn't open up the application.
No.
It knows what it was.
So you're using Cortana as a speech, you know, another interface for the way for your user to interact with your app.
Exactly,
Sweet,
without
really
losing
sweet.
context of what they're doing.
Yeah. Yeah.
One more thing that I've done that I think is pretty cool. Add go to sleep to my to-dos.
Do you want me to add go to sleep to your to-dos?
Sure.
Done and done. Here are your top to-dos.
There you go. And it just does it for me.
Yeah.
You know, I'm doing something. Oh, I need to do something. Okay, let
Yeah.
me ask Cortana real quick to do it, to add it
That's
to my list.
so much easier than, oh, okay, find
Open the
tile,
application,
open the app, type
start
it
typing.
in.
Yeah, exactly.
This is exactly what more personal computing's about, isn't it?
You know, it's just being there for you whenever you need it and
Yeah.
understanding what you're doing. So
Nice.
if you go now to the application, you'll see that go to sleep has been added.
Yeah.
And it's right there, so I
Nice,
can
nice,
complete it. So after this, I have to go to sleep. So how does this done? So
Yeah.
first thing you need to do is you need to have what's called a voice command definition file.
Yeah.
It's essentially an XML, and you see a pattern here. We use XML for a lot of configurations. It's an XML that's ships with your application.
VCD, voice command definition.
Yes. Or it could be a file that you've generated into your application, so you can have more dynamic data into this, information. So what you can do is you can specify an app name that you want this to be recognized by. If you don't specify one, it uses the app name of your application.
Yep.
And then you simply create commands. So in this case, I have the first command is show my to-dos. And
Yep.
here I say show my, and I use the built-in app name. If I don't want to use, what I can do is I have an option to actually specify where I want my app name to be called. You do have to have your app name into the command.
So here's the difference, isn't it? Because on 8.1 phone voice commands, we had this, but you had to have the command,
At the
voice
beginning.
command at the beginning. Whereas
Yes.
now you can put it anywhere
Anywhere
in the
you
phrase,
want,
which
yeah.
is much more, again, more natural and how a person would tend to use speech to interact. It's not quite as rigid as the old voice commands thing was.
Yeah, absolutely. And you can create more than one command for the same option. You know, here I have explicitly specified. I can specify that the phrase needs to be before or after the phrase, so I can do both. So I don't have to create two different commands, etc. And you can see here it has an option to navigate. So by saying navigate, what happens if when I launch Cortana and I say show my to-do, it will navigate to the application, to the foreground. It will open up the application.
Okay.
And then it will pass whatever data I've passed to Cortana, if I have any data.
So that's the foreground app.
Yes.
Yeah.
I have two commands here that are in the background. So you
right.
can see the what's on my to-do and add something to my to-do. So you can notice here that these are using a voice command service. They don't have a navigate.
No.
So this is where you specify the background task that will handle
Yeah.
these notifications.
Sweet.
You can see here also that I've created this to-do phrase topic. And it's just natural language. So this can be anything that I say.
Yeah.
So I can say whatever I need to do, and this will be passed to my background task to handle and do whatever it needs to do.
Okay.
It's very simple to do.
And just, yeah, so you're going to say about language there? Because this,
Yes.
this obviously is US English, but you can actually put multiple command sets in here for loads of different languages.
Many
can't you?
different
Yeah.
languages that are supported by Cortana, yes.
Yes, yes.
Absolutely.
Yeah. Well, the voice commands is, this we said, this bit would work in non-Cortana territories as well, wasn't
Correct.
it? So I'm not sure how many languages are supported, but it's there's quite a number of them, isn't there? I think.
Yes. I don't have the list, but you can definitely find it out, yeah.
Yeah.
Not sure if the voice command service will work if you don't have Cortana.
No,
It won't respond back to you, but
No.
to open up an application, yes, it will definitely
Sorry,
work.
yeah, so the first
Yes.
bit, the launching the foreground app will work.
Yes,
Yeah,
absolutely.
I guess that, yeah.
Now, once you have this file, either shipping with your application, you've generated it,
Yep.
you need to register this with the system. So usually you do this when you launch the application. So, for example, here is a simple, I do it when the application has been launched.
Yep.
I get the reference to the file.
Yep.
And
And then just call
And
install command definitions from storage file async.
yeah, and I just pass that file, and then that's already ingested by Cortana, and Cortana knows what to do with my application.
Yep.
One last thing is to handle the background tasks. I have to add a new runtime Windows runtime component. So I have this to-do voice service.
So this is
here.
where the background launch smart stuff is. This is what handles those commands. That
so I have this service
Yep.
to see what it looks like. To actually be able to use it, I need to specify in the manifest. So let me open up the manifest with the code. Here it is.
Yep.
So here you can see this is where I specify the name, the voice service endpoint, the same one I used in my voice command definition file, my VCD file. And I've specified this as an app service.
Yep.
Yes, and I think we'll talk about app services later today. Right?
Yeah, we are. We've got a session coming up on app services. Yep.
Great.
Yep.
So this is just a way for Cortana to call into my applications and use this application.
Yep.
So the last thing to show is how the service looks
by
like.
the way, you'd have to actually go into the code view of the manifest for that. It's not actually exposed, I think, through the editor, the kind of GUI editor.
You have to do it in the code.
You have to go and edit it yourself. Yeah. Yeah.
Like it's very simple to add.
Oh yeah.
Yes.
No big deal.
So just another background task. I know we've shown many different background tasks here, but it's the same way you've done it.
Yep.
To note, this is actually a XAML rendering background task.
Oh, okay.
And which is pretty cool because what you can do is, you saw I had different tiles for different tasks that I have. You can actually put images, and you can actually use XAML to render different types of images. So if I wanted, I can put the image there, and I can do some cool things. So I can use XAML to render different tiles.
Draw
on top of Cortana, so I have that access there. So I can do that. So what happens is, I get the app service trigger details.
Yep.
And I create a voice service connection. So voice service connection, oops, yeah, that was pretty. The voice service connection is kind of my tunnel to talking to Cortana back and forth. So I can, ask Cortana can send back what the user has said, and I can tell Cortana to say something to the user, for example.
So this is like the app services communication channel.
Exactly.
So we're going to talk about that
later
in a short while. App services.
Yes.
Yeah.
And I have a voice command, user messages that I can use throughout my my background task to send back messages back and forth. And finally, once I know what the user has said, whether a what command or a new command, let's go to the new command. I think that's more fun. Once the user has said new, I can use the voice command properties to get the to-do phrase that the user has said. So whatever, go to sleep, for example, in this case. I can create a response message and a repeat message. Yep. This is when I want to ask the user, are they sure? So that way, in case the first time didn't understand them, you need to show the repeat message. And then I create a response for prompt. That way, Cortana knows that this is going to be for me asking the user for something.
Yes.
And then I call request confirmation of sync by sending this response.
Cool.
And Cortana just takes this, what I wanted to say, starts listening. Stop it. Starts.
Said her name, and there she
yes.
There she was.
I haven't trained her to understand just me. You create a response, and you wait for the user to say yes, no, sure, whatever they need to say. Once you have a confirmation, you do what you need to do, and you create a new user message, say done and done, and then you create a response by sending the response and the content tiles of, you create content tiles of what the to-do items are, and you send those with the response.
And that's what get displayed on
as
the
little tiles.
Cortana
And those are the
UI.
ones you can do with XAML. You can draw different things on those.
Nice.
Yes.
That's really sweet. Yeah.
And it's very simple to do, and if people are interested in downloading this, just go to the GitHub page and just download the.
Yeah. Well, all the samples from this MVA, we are going to put them all up together. And,
yes. And my best friend actually has also this as well, so they can look at that as well.
Nice. Yeah.
Okay, I think we have one last topic, which is identity.
Yeah.
So we have with Windows 10, we introduced a new way to do authentication and to do identity. So we call it Windows Hello, and we also created Microsoft Passport to make it easier for developers to create secure identities for different services on the platform. So Windows Hello allows you to do biometric authentication. So it supports face, supports iris, and supports fingerprint. And all these different things require specific hardware, and there's already hardware available. I have this Intel RealSense camera that you can get online right now that has a depth sensor that's supported for Windows Hello, so you can recognize, I can log into my machine without putting a password in, for example. And we've made it super fast and very secure. So one of the requirements to build this was from the enterprise, that this needs to be very secure so you can't fake it. So if you put a picture in front of this or something, it won't just work. So it needs to be actually you to recognize this. So it's super secure. And then we've created Passport to simplify authentication through using Windows Hello and authenticating through different types of services just by creating a more a safer authentication with those services. So it creates a public and private key that you can use instead of your passport, so you don't have to, instead of your passwords, you don't have to pass your password every time so someone can steal it. So if someone steals your passport key, they have to also steal your machine to also authenticate with a service that supports Microsoft Passport.
Cool.
So I just want to show real quickly what this looks like.
It's a good goal, isn't it, to get away from passwords and this old way of logging on to systems. And again.
So you can see here, I've kind of put my hand over the camera so it doesn't log me in right away. So you can see it's looking for me.
Yeah.
You know, if I want to log in, I simply just take my hand off the camera. It knows who I am. It automatically logs me in. I don't have to do anything.
Really quick.
It's super quick. It's very reliable to use. So we've done a lot of work to enable this for developers.
So this isn't just about logging into Windows. You can actually build this in these kind of recognition features right into your app.
Applications.
You could have a game where people could, use this face recognition to switch context to a different user of a game or something like that,
absolutely. Yeah, and for developers, it makes it very easy to implement this with your services as well. So with pairing it with Microsoft Passport, you can make it a lot more secure for your users on that device so that they can be confident they can just use this. And plus, they don't have to enter the password every single time. The password in no way is stored in the cloud or anywhere.
No.
And with the pairing of things like DCM chips, or I think that's what it's called, it's a lot more secure. People can't just steal your password, etc., because you don't use your password anymore. The way it works is we use what's called Microsoft Passport to store these credentials that are created with your backend, and we keep those safe with Windows Hello, so with your biometric authentication. So in order to authenticate with Microsoft Passport, you first need to log in first to a service. So I log into a service real quick, and I talk to the server. I say, okay, now I want to pair with Microsoft Passport. I exchange keys, and then I lock my key inside of what's called this little folder. And the only way to unlock this folder is if I use my biometric authentication. So biometric authentication is basically used to pair your account or your face or whatever your biometric data to a specific third-party account. And the way it works is to provision this, a user would log in for the first time to the service as they would normally. And then you would use Windows Hello to open up, unlock this credential manager to store this new key. And once you store this new key, then the server and your device can talk using this key anymore. They no longer have to use your password to do this. And to use this key, they have to use Windows Hello or your camera or whatever to talk to it. To use it, next time you want to use it, user opens up the application. The application asks the user, okay, I need to authenticate and to get this key. Ask the user to authenticate with Windows Hello in order to get the key. Once user has identified themselves as the user that's actually on that device, the developer has access to that key and they can send it to the service to use. So real quickly, just to show you how this looks like. Here we go. Actually, I have a different branch. I'm going to switch to a different branch. There we go. I'm just going to launch this. So you can see now I'm prompted to log in as a user, and I have two options: to sign in with Microsoft Passport or just sign in. So if I sign in with Microsoft Passport, what will happen is I would generate these keys to talk to the server. I will have to use this once. the service identifies me to make sure that's me, so he can actually open up the storage for these keys.
Yeah.
There it goes. It pairs it up with my account, and then I'm logged in. Next time I launch the application, now that I've paired with Microsoft Hello my account on the server side, oops, I no longer have to enter a password or anything. I can just authenticate with face recognition, and it automatically logs me in without actually entering a password or anything. Because it has done the authentication with the backend.
Nice. Yeah.
So I think that's one of the last demos that I have. One last thing to note on this is many people have questions. How can a 4-digit PIN that's a requirement to use Windows Hello be more secure than using your password? And the reason why is because the 4-digit PIN is tied to a device that you're using. That it's only valid if you use it on that device. So it's not shared. So if somebody steals your device, they also have to know your PIN, or if someone finds your PIN, they have to find your device. So they can't use your, for example, Microsoft account if they steal your PIN. If they steal your password, they will be able to use it anywhere they are. And on top of that, if you use a TPM machine that most enterprises have, TPM provides a lot anti-hammering support to help storing these offline attacks, and the keys are hardware bound, and it's a lot more secure in terms of availability to the user. So
it's a step forward in security overall, and really.
Absolutely.
Yeah.
So that's all I had for this. We talked about gesture and the history of how we got here. We talked about inking and the support that we have for pen and input. We talked about speech, Cortana, and all the speech recognizer and speech synthesis APIs, and we talked about identity and how we were making that easier for users to identify. We call these human technologies, and this is just the beginning, essentially. So I think that's all we had. I think there's a...
That's really great. Thanks a lot, Nikola. That's clever
I hope
stuff.
that was... If you have any questions, always feel free to...
Yeah, so that's really good.
So is Windows Hello available to users?
Home users.
Yes. Jerry has all the answers for us.
Hi, Jerry. How you doing?
Jerry.
Yeah.
So is Windows Hello available to all home users? The answer is yes. And can Windows Hello be used with specialized hardware? The answer is no.
You do need specialist hardware.
Yes.
Cool. Well, that's been really, really great stuff. Thanks, Nikola.
You're welcome.
It's been great to have that. I'm afraid in the next session we're going to get down into kind of much more boring stuff than all of this. Well, it's exciting.
No, I don't think so.
App-to-app communication, and then we got app services, which was a part of what you showed there. So, so we're going to take a 5-minute break, and hope you'll join us back for more of the Developer's Guide to Windows 10. Thanks.
Thank you.